So we've talked about increasing, decreasing, max and mins. Now we're going to talk about the shape or the curvature. Now, one thing I actually put in your notes though, the first derivative, people sometimes gets this confusing. Make sure for the first derivative, that's to find out increasing, decreasing, max, and mins. So if you need to find out increasing, decreasing, max or mins, use the first derivative. The second derivative is all about the curvature. And another word we use for that, concavity. Okay? So second derivative is concavity, and then we're going to learn in the next spot, we're also going to do inflection points. So use these two for the first derivative, and these two we use the second derivative. Okay, so this I want you to put under concavity. Okay, so first of all, you have to understand what concavity is talking about. So think of it if it's upside down. If you pour the water on top here, it runs off, right? If that means it's concave down, it's falling out. If it's concave up, the water falls in and fills up your cup. All right, so first of all, understanding what concave down means, it's curved upside down. Concave up, it's curved concave up. All right, so like I was saying before, f prime of x is decreasing when the first derivative is negative. If the second derivative is negative, it's concave down. So, when we look at when the first derivative is increasing, if the second derivative is positive, it's concave up. So sometimes we just say down and cup. So first derivative negative, less than 0, upside down. Second derivative positive, up, right side up, concave up. All right. Oh, so this kind of says everything. So maybe you want to, maybe this is a better way to conclude it. I just kind of was rambling, I guess. Okay, so let's figure out where is it concave up or concave down. So we're going to do everything that we did with the first derivative, now with the second derivative. So we take the first derivative, use your power rule, multiply, subtract 1, multiply, subtract 1. This is our first derivative. So to find our second derivative, we do the derivative of the derivative. Do your power rule again. Now we're going to set the second derivative equal to 0 to find if it's concave up or concave down. So this part is not new. You're just doing it with the second derivative rather than the first derivative. So I'm going to move over the 6, divide by 12, and we find the second derivative equals 0 when x is 1/2. So we're just going to use our chart. Now let's think about what this is saying. 2x to the third has the basic shape of that wiggle, right? I would expect the first part of the curve to be concave down and the second part to be concave up. The part where the second derivative equals 0 is where it changes concavity. See how this part is curved down and then it's curved up? So that happens where x is 1/2. So I'm just going to take my negative infinity to infinity and just insert, just like we did with increasing, decreasing. So negative infinity to 1/2 and 1/2 to infinity. Now we're going to plug values. Let's try 0 because that would be in this first interval. We're going to plug that into my second derivative. So if I plug 0 in for x, 12 times 0 minus 6, that's negative. This is the second derivative is negative. Then I know that y is concave down, which is what I expected to find for that first part. Now I'm going to plug 1 in because that's in my second interval. If I plug 1 back in for x, 12 times 1 is 12, minus 6, that's a positive value. So y is concave up, which is what I expected to find. All right, so then they always like you just to make y is concave down from negative infinity to 1/2, and y is concave up from 1/2 to infinity. So they always like us to make a nice little sentence, nice little statement when we're done. All right, that's for letter A. Letter B is just our quotient rule. So I'm going to clear off the screen. So this one's a little bit longer. So now I have f prime of x equals, how do we do the quotient rule? Square the bottom. And it's the bottom times the derivative of the top is just 1 minus the top times the derivative of the bottom is also 1. Be careful with subtraction. I'm going to write all this out so you see what I'm doing. Distribute the 1, we get x minus 3. Distribute the 1, and technically let's distribute negative 1 because we're subtracting. And now our x's cancel. So our first derivative is negative 4 over x minus 3 squared. Now to find our second derivative, you know what? You know it would be easier rather than doing our quotient rule, since this is just a constant, let me rewrite this here as negative 4. Let's just bring this up and make that a negative exponent. It would be an easier derivative. So then I can just use my power rule for my second derivative. Now I'm taking this first derivative, taking the second derivative. Negative 2 times negative 4 is 8. X minus 3 to the negative third times the derivative of the inside is just 1. So a better way to write this is A, 8. Let's bring this back down to the bottom to the third. Okay, so we can see, since there is not a variable in the numerator, the second derivative cannot equal 0. But what we can see is it does not exist when x equals 3. This should make sense. This is a rational function. This has a vertical asymptote at 3 and a horizontal asymptote at 1. If I plug 0, first of all, I can see this will equal 0 at -1. This is going to look like this. And then this is going to be up here. All right. So sometimes we can take what we know about the original graph, and you might say, I didn't know what that original graph looked like, but hopefully you kind of remembered some of the stuff as I went through. All right, so we're just going to use where x is 3. That was where the original function had an asymptote. That's where it breaks up. And I'm going to go -infinity to 3, but I'm not going to include 3 because 3 is not, it's an asymptote. And then I'm going to look from 3 to infinity. So let's plug in 0 because 0 is always the best number to use. That's in this first interval. If I plug 0 back into the second derivative, I get -3 to the third, which is -27. That gives me a negative value, so f is concave down. Do you see this? It's concave down. That matches what I think it is. Then I'm going to plug in 4. That's in this interval. If I plug 4 in, I get a +1 to the third. 8 divided by 1 is a positive value. So f is concave up. That's on this part. That also makes sense. So I've run out of room, but it's concave up from 3 to infinity, not including either one. Concave down from -infinity to 3. Now, you might want to watch this video a couple of times just to kind of sink in, and then we'll do some homework.